Okay, so we're going to work on problem number 6. That was the rocket that gets launched from rest with an acceleration of 29.4 meters per second for 4 seconds. It then runs out of fuel, continues upward for a little while, and how high does it go above the starting point? So the first question, just how high it goes above the starting point, we'll talk about. We also asked these other two questions in class: the total time in flight and the velocity when it returns to the launch site or back when d equals 0. All right, so let's start with the first question. So as you can see, we have our drawing, which is step 1 of our process. As always, we've listed our variables. In order to find the maximum height, we're going to have to do a couple things. First, we're going to have to figure out how far it goes during the accelerating portion, and then how far it goes during the portion where it's in free fall and the engines have cut out and it goes up to a velocity of 0. So let's start with the first part. We know this information, and we're looking for the displacement, or dy in this case, the height in the y direction. So that formula, the one that we need to use there, is d equals 1/2 at squared plus vit. That's the formula that doesn't include final velocity, since I don't know what that is. So substituting my values that I do know, 1/2 times the acceleration of 29.4 times the time of 4 seconds squared, plus an initial velocity of 0 times 4 seconds. That is obviously 0, since the initial velocity was 0. So now we're ready to calculate that that displacement. So I need 0.5 times 29.4 times 4 seconds squared. Gives me a displacement in the y direction during the acceleration of 235.2 meters. So my first displacement is 235.2 meters. So that's the displacement that it has during the engine burning portion. When the engines stop, it goes into free fall and continues upward until gravity brings it to a stop and then brings it back down to the ground. So in order to figure out how high it goes up, we know that the final velocity up at the top is going to be 0. We know the acceleration is going to be gravity, or negative 9.81 meters per second squared. I'm looking for the displacement again, the dy, but I don't have time and I don't have initial velocity. So I've got a problem because I'm missing 3 variables. But I realize that the final velocity during this portion of the trip will be the initial velocity during this portion of the trip. So if I can figure out the final velocity after the rocket's done firing, I'll have the initial velocity for the free fall. So I'll do that quickly. I'll come over here. Now, knowing that I'm looking now for final velocity, I need an equation that doesn't have displacement, that has final velocity. So I'll do equation number 2, Vf equals At plus Vi. Substituting in my variable, or my knowns, the acceleration of 29.4 meters per second squared times a time of 4 seconds, plus again an initial velocity of 0. Going back to the calculator, 29.4 meters per second times 4 seconds gives me an final velocity of 117.6 meters per second. 117.6 meters per second. The units check out because my acceleration in meters per second squared, my time in seconds, will leave me with meters per second. So now I know the final velocity of my rocket when it gets done firing is 117.6 meters per second. That's going to be my initial velocity up here. So now I know initial velocity, final velocity, gravity. I'm looking for dy. I need an equation without time. And so that would be equation number 4, which is Vf squared equals Vi squared plus 2AD. Substituting my values, I get final velocity of 0, initial velocity of 117.6. I have 2 times my acceleration, which is negative 9.81 meters per second squared, and dy is what I'm looking for, the height that it goes well in the free fall section on the way up. So doing a little algebra, my distance is going to be negative 117.6, and I got to square that, divided by a negative 19.62. That's 2 times negative 9.8. So my two negatives will cancel out. So that height over there, let's go back to the calculator, 117.6 squared divided by 19.62 gives me a height of 704.88 meters for the part where it's in free fall after the rockets have stopped. So I can add those two together, which will give me my total height, my max height, by adding those two together. So my max height is 235.2 plus 704.88. So I got 704.88 plus 235.2 for a total of 940.08 meters. So 940.08 meters is my max height. Okay, so there is the answer to the question that was on the original worksheet. Give me a second to clean this up and we'll come back and answer the other two, the total time in flight and the velocity when it returns to the launch spot. Okay, so now we need to go on to the new ones that we added during class. That's the total time in flight and the velocity at the return to launch. Let's start with the total time in flight. Okay, so the total time in flight, we'll call it big T, it's made up of 3 parts. We got the section where it's accelerating due to the fuel being burnt. We'll call that T1. So you have a T1. You have this section when it's in free fall, still on the way up, going up to the maximum height. We'll call that T2. Oops. We'll call that T2. And you have the time it takes to get from the maximum height, where the velocity is 0, back down to the ground. So we'll call that T3. So adding up those 3 will give us the total time. We already know that T1 is 4 seconds. That's given to us. So let's start and see if we can find T2. So T2, I know I have an initial velocity of 117.6. Got a final velocity of 0. I know again that we're acting under the acceleration due to gravity, negative 9.81 meters per second squared, and I'm looking to find what we're calling T2. So in order to do that, I'm going to need a formula that doesn't involve distance but has time. And that's going to be VF equals AT plus VI. Substituting my knowns, final velocity is 0. The acceleration is negative 9.81 meters per second squared. Time is the variable I'm solving for. And my initial velocity was 117.6 meters per second. A little subtracting and dividing. Time is going to be equal to negative 117.6 divided by a negative 9.81. Pull up our calculator. Do 117.6 divided by 9.81 gives us a total time on the way up of 11.99 seconds. For the time when the rocket stops accelerating until it reaches its maximum height. All right, so now we're ready to move on to T3. Okay, so we'll call this guy T sub 3, the time it takes for the rocket to go from the maximum height back down to the ground. So we know its initial velocity is going to be 0 because it starts up at the top. We still know the acceleration is going to be that due to gravity. The displacement, if you remember from our max height calculations just a little while ago, is 940.08. So 940.08. Now that's going to be a negative because it's falling from a height up here down to there. So, and time T3 is what we're looking for. So again, I've got an equation without final velocity. So I need to come up with T3. So we'll do T3. So I need an equation without final velocity. So my equation without final velocity is displacement equals 1/2 AT squared plus VIT. I'm going to have a displacement of 940.08. I have my 1/2. Got a negative 9.81 T squared plus 0T. So again, that just becomes 0. So I've got a fairly simple quadratic. Negative 940.08 equals 1/2. Let's do that multiplication real quick there, huh? Let's make that negative 4.095 T squared. Dividing both sides by the 4.095. So 940.08 divided by the 4.095 gives me a, yep, no problem there. What do we have? Nope, one too many decimal points in there. Let's delete that. There we go. So that gives me a T squared equal to 292.74. We'll just take the square root of that real quick. It's going to give me a T of, what was that? 15.16. 15.16 seconds. Okay, so now I'm ready to go back up into my equation. I got T1 of 4 seconds. We calculated T2 of 11.99 seconds. and we calculated a T3 of 15.16 seconds. So again, we'll just add those times up. 4 plus 11.99 plus 15.16 gives me a total time of 31.15 seconds. All right, so now finally we need to answer the last question, the velocity at the return to the launch height. So we're looking for now this final velocity right here, velocity when it gets back down to the ground, the actual final velocity. The easiest way to approach this is, since we know it starts at 0 up at the top of the fall, and we know that it falls the negative 940.08, lost my little 8 there, 08 meters, we can easily figure out what the final velocity is. Again, using the formula that doesn't have time, formula number 4, final velocity squared equals initial velocity squared plus 2AD. We know that final velocity is what we're looking for. Initial velocity is 0. Got 2 times the negative 9.81 times the distance of negative 940.08 meters. So doing a quick calculation, we have 2 times 9.81 times 940.08 gives me a total there of 18,000. Now I'm going to have to take the square root of that. So the square root of my answer gives me a final velocity of 135.81 meters per second. So final velocity of 135.81 meters per second. There's a slight problem here though, because I know that the rocket is traveling in a downward direction, but my velocity came up positive because I've got a negative 9.81 and a negative 940 for the distance, which makes sense. So when I take the square root, I'm getting 135. Here's the one thing you have to remember. Back in 5th grade, or whenever it was when we first learned about square roots, we asked, what's the square root of 25? And back then, we made a big deal out of saying, remember, it is positive or negative 5. Because both positive 5 times positive 5 and negative 5 times negative 5 will equal 25. Same thing applies here. This could be either a positive or a negative. The calculation doesn't know what it is. It's requiring you to know we're traveling in the down direction to make it a velocity of negative 135.81 meters per second. I'm sure there will be several of those mistakes made on quizzes and or tests. So please remember step 5, check your answer, make sure you've got it going in the right direction with the correct unit. Okay, see you in class.